On June 22, a French nuclear reactor did not stop because operators lost control. It stopped because the river beside it was getting too warm. At Golfech, EDF took Unit 2 offline as the Garonne approached a regulatory temperature limit. That sounds small, but it is the key to the whole story. A power plant is not separate from the landscape around it. The World Meteorological Organization described a widespread late June heatwave across Europe, with records falling and infrastructure under stress. Copernicus Sentinel imagery showed land surface temperatures above 50 degrees Celsius in parts of France and northern Spain. That is ground temperature, not air temperature, but it shows how much heat the system had to absorb. Heat hits the grid first through demand. RTE said French consumption would average about 58 gigawatts that week. In strong heat, each extra degree can add roughly 0.7 to 1 gigawatt of demand, and cooling added about 10 to 14 gigawatts compared with seasonal weather. That demand does not appear as one giant machine. It appears as millions of small decisions: a fan turned on, an air conditioner working harder, a shop trying to keep doors open, a train station trying to move hot crowds. The grid feels those decisions all at once. But the supply side is also physical. Thermal plants do not only need fuel. They need water, air, and legal room to release heat. The river is part of the machine, because cooling water returns slightly warmer, and environmental rules limit how hot the downstream water can become. Golfech was not the only place where climate conditions mattered. EDF also reported output changes or temporary stops at Nogent-sur-Seine, Bugey, and Saint-Alban. At Bugey, Unit 3 was stopped while other units were kept producing at adjusted levels because RTE still needed them for the national grid. This is why the event matters. A heat wave can push demand up while pushing some thermal output down. The grid operator is not solving one problem. It is balancing two weather effects that point in opposite directions. This was not a blackout panic story. RTE said France's supply security required no special vigilance, and that production was sufficient. In Great Britain, NESO issued an electricity margin notice during the same heat episode, then withdrew it after margins improved. NESO also said supply stayed secure throughout. That is the hidden part of modern electricity. Reliability is not a single reserve number. It is forecasting, interconnectors, generators rescheduling outages, demand response, flexible plants, and operators making small corrections before customers notice anything. Solar can help during a clear hot afternoon, and that matters. But the hardest grid story is often the timing. People still need cooling after sunset, wind can be low under a high pressure pattern, and the evening peak still has to be balanced. That is why an electricity margin notice is not a power cut warning. It is a signal to the market that the system wants more available capacity. The important detail is that the tool worked, additional capacity and demand-side response appeared, and the notice was withdrawn. The lesson is not that nuclear is bad, or that solar saved everything, or that Europe nearly ran out of power. The lesson is sharper: every power source has weather behavior. Heat changes demand, water temperature changes thermal plants, wind changes reserves, and the grid has to make all of that true at the same time. So the real question is not whether Europe survived one hot week. It did. The real question is what we build before the next one: more supply, lower peak demand, more flexibility, different cooling rules, or a grid that treats heat waves as a normal design condition instead of an exception.